No, shall we start today's class? Can we start? In today's class, first, okay, we will discuss the last that remaining questions. Remaining questions. So if you check the questions that you had given last time, then you can see that question number 9, 10, 11, 12. Today we are going to solve that. So can you hear me? Is the sound clear? Please, you can respond by raising hand. If my sound, my voice is clear, okay, then let me start today. Be ready with copy and pen. Some of you have already done those numerical problems. One more time. Today we are going to revise that, repeat that. The first numerical problem is about expressing a general number into scientific notation, okay, and then second we will do conversion, and finally one problem about volume of a spherical body, that is volume of football. So we'll learn how to calculate, and after concluding those problems, and we can say that lesson first chapter measurement is over. If you do have any queries and question about measurement topic, then later we can discuss. Yes, Jendra, good. That is the correct formula for finding volume of sphere. 4 by 3 pi r cube. You are correct. Football is a sphere. So to find the volume of football or sphere, we have formula 4 by 3 pi r cube. R means radius. Okay, we'll do that problem. Then after, okay, in the second phase, today we are going to start new lesson. Second lesson, second chapter, the force. So first, let's do those problems. Let me start sharing the screen. Okay, then we'll do. Please just wait a minute. The question is like this. Yes, you can see. So up to number 8, class 9, we do not have any problem now. So we know the answers of the questions up to number 8, and even you know how to express, okay, the big and small number in power of 10. So you can see number 9, number 9a, there is a large number, you can see. So how to do it? I'll write on the same screen. The number is about okay, it's very large number. So you have 0, 40 after 2, then again 85, then at last you have 50. So how to convert this a number? Okay, this a number in power of 10 in scientific notation. The answer will be like this. Okay, it is okay, if you count, then you can see 2 point, okay, here you have 0 0 0 0 8 5 into 10 to the power, and we know, so when we write a scientific notation of big number, so we always shift decimal to the left side. As we shift decimal to the left side, and every digit counts positive power. So you have 50 at last, 5, then okay, number 5 6, then you have 8 7, then finally 0, okay, 40 after 2, that means 11. Okay, then it will be 2.00085 in 10 by, okay, 11. So we are solving question number 9a. So converting this number into power of 10. Can you see there on the screen or not? Please. Then okay, just like you can see, after decimal there are 40, then 85. Sometime we can neglect, okay, sometime we can neglect these digits. If we find okay, many zeros after decimal, then that number is very small. So this answer or this number can also be written like this: 2 into 10 to the power 11 directly. Got it? Okay, please check your answer. Now let me go to number B. Number B is a 0 point. Okay, you have 0 0 0 0 0 0 0 0 0 3 5 6. means it is very small number. It is smaller than 1. So number B can be written like this. Okay. And you know, when we express a small number in scientific notation, so we shift decimal to the right side. And shifting decimal to the right side means a negative power increases. So each digit counts consecutive negative power. So we have here, if we shift decimal, okay, just after 3, then up to 3, okay, with 3 there are 9 digits. So obviously the answer will be 3.56 into 10 to the power minus 9. Okay, the decimal is shifted to the right side and each digit counts negative 1. Then finally, when we go up to 3, there are 9 digits. So it is minus 9. Clear? Okay, let's go to number C. Number C is 9 we have here. Okay, then 1, 2, 3, 4, 5, 6, 0, then decimal 4, 5. Okay, so if you are asked to write the scientific notation of this number, yes, actually we write like this, number C. Okay, 9 point, okay, yeah, so we are shifting decimal to the right side, sorry, left side. Okay, it is also last number, we are shifting decimal to the left side. Okay, after 4 there, so it will be 9, how many 0? Obviously 6. 2, 3, 4, okay, 5, 6, then 4, 5, yeah, into 10 to the power 6, like that. But writing in such a way is also not convenient. Okay, we use scientific notations to, okay, take less space and to express the number in an easy way. So in this case also we can neglect this number. Then finally we can write that, because after decimal there are many 0, means that number is very small than 1. Okay, so we can neglect these digits. Then directly we can write 9 into 10 to the power 6. Okay, the final other answer is clear. The method is, obviously we are shifting decimal to the left side. Then we have 9.000000045 10 power 6. Since after decimal the digits are so small, so we neglect those digits, and finally we write the 9 into 10 power 6, like that. Okay, now let's go to number 10. Number 10 is to convert that kilometer into millimeter. The relation between kilometer and millimeter is, you know, 1 kilometer equal how many millimeter? You know, 10 to the power 6 millimeter. 10 to the power 6 means it is 10 lakh. Then, okay, then yes, okay, 64 kilometer. Then we have what? To convert kilometer into millimeter means converting bigger into smaller. We multiply. So we have 64 into 10 power 6. And finally, if we, okay, want to add more that power, then we can keep decimal here, just in front of 4. Then we have final answer 6.4 into 10 power 7. Okay, that's shifting decimal to the left side. Always that makes the increase in the positive power. So there was 6, that shifting decimal to the 1 digit left. Then we have 7. 6 becomes 7. So 64 kilometer means 6.4 in 10 power 7 millimeter. Okay, clear? And then next we have, okay, 72 kilometer per hour into meter per second. We're converting kilometer per hour into meter per second. Okay, 72, yes, kilometer is very easy. Everyone knows. Then we can directly do this. Okay, 72 into 1000 means 1 kilometer equal 1000 meter. So 72 kilometer means 72 into 1000. And whole upon we have 1 hour. 1 hour means 3600 seconds. 60 into 60. So 60 into 60. So 1 hour has 3600 seconds. And the finally, so if you calculate, then we'll get answer. Okay, it will be 20 meter per second. So 72 kilometer per hour is converted into meter per second, which is equal to 20 meter per second. Understood? Okay. Next, please. Next question is, we have 5 mm square, millimeter square into meter square. Okay. The relation between millimeter square and meter square is, you know, Okay, 1 mm millimeter square equal, yes, it will be 10 to the power minus 6 meter square. Okay, 1 mm is 10 to the power minus 3 meter, but since it is square, so there will be 10 to the power minus 3 into 10 power minus 3, then it will be 10 power minus 6 meter square. So converting 5, okay, mm square into meter square, it will be obviously, yes, 5 into 10 power minus 6 meter square. Clear, students? Okay, after completing these numerical problems, I'll come back to you. Then we'll discuss in short about these questions. Fine, the last question is there. The diameter of a football is 14 centimeter and calculates volume. Diameter is 14 centimeter means you can find radius, and the radius is half of diameter. It will be 14 by 2. The final answer is 7 centimeter. And then we have here volume B equal, since football is a sphere, to find the volume of sphere we have 4 by 3 pi r cube. Now you can substitute value 4 by 3 constant as it is, pi is also constant, and its value is 22 upon 7, and r cube, it is 7 to the power 3, 7 cube. Okay, and the final answer, so we'll get, after calculating, the volume of a football is 4,312 centimeter cube, like this. Okay, it is a small number, since we can write in this way, out of 10 centimeter, it will be like 10 to the power 3 centimeter cube. Clear, class 9? Yes, the diameter of football is 14 cm. First, we converted diameter into radius, and radius is 7 cm. And we put formula, okay, for finding the volume. Volume of sphere is given by 4 by 3 pi r cube, and putting the value. So at last we got, okay, the volume is, yes, 4,312 centimeter cube. So which can also be written as 4.312 into 10 power 3 centimeter cube. Clear?
Sir, in that 9 number, the diameter of football, my that 1437.3 centimeter cube it comes.
Okay, let me see. Let me check that one. 4 into 22 into yes, 49. Yeah, the answer. Then divide by 3. Yes, you are correct. It will be 1,450. Yeah. What answer I said at the time? Okay, that is not the final answer. Sorry for this, class 9, that I forgot to divide by 3. Yeah, the final answer, the final, volume of football, whose diameter is 14 cm, is 1,437.33, okay, centimeter cube. Thank you so much. Yeah, that is the final answer. Okay, now please let me come back to you. Yes, class 9. So we try to solve some of the numerical problems. First, we just practice, okay, converting the number into power of 10. In some cases, when we have the number that has digits, that many digits, and especially containing 0 after decimal, okay, and means that number is very, very small number, and we can neglect like that. Just like we did that in number 9C. So we directly write 9 into 10 to the power 6. Though there was, okay, 90000.45, but at last finally we neglect that 0.000045, and we write only, that is, okay, that is 4, 9 into 10 to the power 6 centimeter cube. Understood? Okay, class 9. Now I have one word. Let me ask you, okay? So anyone can give answer. The word is zenith. 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 Did you hear me?
Yes,
The
sir.
word is yes, zenith. Can
Uh,
you say what is meant by zenith?
the point in the space just over the observer's head.
Yes, thank you, Subham. Yes, you're right. You are correct. Yes. Very good. Congratulations, Subham. Thank you. Yeah, I repeat the same term. Okay, zenith. Please, others, please listen. So on the on the surface. Okay, when you stand perpendicularly, when you stand upright, okay, straight, and just above your head. So when we find the point in the sky, that is the highest point. That is the farthest point. Okay, in the vertical that direction, and that highest point in the space, the highest point in the sky, just above the observer's head, is called zenith. Okay, that is zenith. So when we find the sun, okay, at that point in the zenith, and sun rotates, and after rotating, what do we find? Again the sun reappears in the same point in the zenith. Okay, after some interval, that means after 24 hours, and that time period is called zenith. Okay, now after knowing zenith, okay, yes, zenith, zenith, zenith. Okay, now do you know that is relation between that 1 day and second? That means I just ask you to say how many seconds are there in 1 day. Now anyone can give answer. You have to say numerically. Yes, good. Yes, yes. Please, others also please respond. So how many seconds are there in 1 day? You are asked to say,
86400.
okay, that the equivalence can, yes, 86,
400.
86, yes,
400.
86400. Thank you so much. Yes, you're right. Correct. Yeah, yeah. It will be 86,400 seconds. Yes, yes. Yeah, 86,400 seconds. Good. Okay, 864 and 000 seconds. Okay, now let me know from you grade 9. So if there is any topic in the first lesson measurement that is doubt or confused, then we can have a short discussion. So in lesson first, okay, we read that two types of units: fundamental unit, derived unit. Then we came to know, okay, conversion of units. And we also came to know that, okay, to find out the fundamental units in shortened derived units. For example, if I say one derived unit joule, then you can easily find out the fundamentals fundamental units that get involved in that. Anyone get confused with relations or topic and finding fundamental units in the derived units? Yes, Shubham Pathak. So, do you have any queries? Do you like to say anything or something about the topic measurement? So, if we recap, if we review, let me again say the topic that we were discussing from last 3-4 classes. We came to know about the fundamental and derived units. Next, so we learned to find fundamental units, okay, of derived units. Just like we practice to find the fundamental units of Pascal and Newton, like that. Then we also, okay, learn, yes, to define to the meaning of different system of units that we discussed last week, FPS, MKS, CGS, and SI system. Okay, then we learn converting the units, okay, from one unit to another. We just like we practice converting kilometer to meter, meter to centimeter, and even we just convert that speed, okay, units of speed, kilometer per hour to meter per second, and meter per second into kilometer per hour. And we also try to convert very big unit of distance, that is astronomical unit. So last time we found that one astronomical unit is equal to 1.5 into 10 to the power 11 meter. And today we just revise some questions. And okay, let me go to Jayendra. Jayendra, do you have any question?
Yes, sir.
Yeah, please, Jayendra. Yes, please go on.
Sir, about expressing any derived units in terms of fundamental units.
Yeah, okay. Let me say orally, okay. So once you are
Okay,
given the
sir.
derived unit, the first thing, the first step you have to take care is to know the respective quantity. So if I say, okay, joule, then you must know that joule is the unit of work done. Okay, joule is the SI unit of work done. After knowing the respective quantity of the derived units, the second step is to know the formula. Just like formula of work is, yes, work can be measured by the formula, then a force into displacement. Force into displacement. Work, yeah, equal force into displacement. So you can see on the screen. The first step is know the respective quantity. Joule is the SI unit of work. And second is to write the formula of quantity. Work is given by force into displacement. And then finally, we have to find the simplified form of factors or quantity, just like the simplified form of force and displacement. Okay, more further we can go to the force, and force is again simplified as mass into acceleration. Okay, by Newton's second law of motion, force is equal to the product of mass and acceleration. That is ma. M for mass and A for acceleration. And displacement is sometimes denoted by D, or sometimes it can be denoted by S also, small s. So M for mass, A for acceleration, and S for displacement. And we need to know that these are the simplified form of quantities. Then we can replace these quantities by their respective units. That's like SI unit of mass is kg. So in place of mass, so we can write kg, kilogram. The SI unit of mass is kg. Okay, then SI unit of acceleration, that is meter per second square. Okay, meter slash second square. Okay, and then the unit of displacement is meter. Means we came to the final step. That s square means that s to the power 2. Okay, you can see on the screen. And then kg, kilogram, meter per s dash square means second, that is to the power 2, and then meter. So this is the final answer. Means you are asked to get the fundamental units of joule, and you have started doing the problem. So you have started finding the fundamental units of joule. The first step, what you have done, you have mentioned the that is quantity. It's like joule is the SI unit of work. First step. Then second step is write the formula of quantity. Formula of work is force into displacement. And if you can go further in the simplified form, then you have gone there. Just like force is again broken into mass and acceleration and displacement as it is. Then finally, so we replace or we put the respective SI units: mass kg, acceleration meter per second square, and then displacement meter. So what we have got, that is kg, meter, and second. You can see over there, kg, meter, and second are the fundamental units that are involved in derived unit joule. Okay, you can write the answer as that you have got in the final step as kg, that meter per second square, and meter, or simply you can just mention the denotation of that units, basic units or fundamental units. Okay, they are kg, meter, and second. Understood? So this is very simple way. This is very simple idea that we can find the fundamental units which are involved in derived unit. Thank you. And now let me come back, please. Yes, others, please. Class 9. Jayendra, Jayendra Dungana,
Yes, sir.
Suvinta. Yes, are you clear, Jayendra?
Yes, sir.
Okay, yes. If you get any problem that regarding other derived units, okay, then you can ask question, please. Feel free to ask any question, please. Then only we can go to new lesson. This is the easiest lesson, easiest chapter. Measurement is the easiest one, and most of the topics you have already read in class 8. Okay, Subhinta. So do you have any question, please? Yes, Subhinta.
No, sir.
Okay. Class 9 students, let me know. Okay, do all the students have science book? Science book, okay,
Yes, sir.
already bought?
Yes,
Okay,
sir.
if you have science book, then you can see the exercise. Okay, exercise of exercise of lesson first, measurement. Then if you get any problem in that questions of exercise, then you can ask me. Got it? Okay. Now we can come to the end of the lessons. If you do not have any, please. So I hope so the students who do not have science book, and then
Sir,
soon you will buy that. Kare,
what are the fundamental units used in physics? Yes,
please, yes, pardon, please, Kare.
sir, question number 3. What are the fundamental units
Kare.
used in physics?
Used in,
Physics.
please, used in which unit, Kare? The sound is not very sure.
Oh,
Father, you can send message, okay?
You can mention in chat,
sir.
please. You can send the message, please. Yeah. Pascal, did you say Pascal, correct? So which unit you said? Was that Pascal? So to find the fundamental units of Pascal, Newton, Joule, then next Watt. Fundamental units in physics means last time what we did, 7 fundamental units, 7. So there are 7 fundamental units, okay, that we use in physics. Those 7 fundamentals are, the unit of length, unit of mass, the unit of time, a unit of temperature, unit of amount of substance, a unit of luminous intensity, and unit of current. Okay, that is not for converting. That is asked to enlist the units, means to write the name of units, fundamental units. Okay, they are meter, kilogram, second, ampere, mole, candela, and Kelvin. Kelvin is the unit of temperature. Candela is the unit of luminous intensity. Okay. Next you have mole is the unit of amount of substance, and then second is obviously time. Okay, kilogram for mass, and for length we have meter. Understood, Kare? So okay, if you are asked
Yes,
to
sir.
convert it or find the fundamental units, then the derived unit will be specified. The particular derived unit will be given. Okay, like Pascal, Newton, Watt, WATT Watt. Watt is also the unit. And then just we did, okay, that is Joule. Okay, you have volt, you have volt also. There are many derived units. So once if you have book, you can check, and then if you get any confused, then next time we will discuss. Yeah. Okay, Sudha, do you have any problem? Any questions, Sudha?
No, sir.
Yeah, clear. Okay,
Yes,
Pralon, what's about you?
No problems.
Okay, then please, this is a question for all. Very simple question. Okay, I'm going to ask you. Can you say one difference between basic unit and derived unit? Voluntarily, okay? Ayush Shrestha, yes, please. Ayush, Ayush, where are you? Ayush, I could see that you are sharing the screen. Okay, let me repeat the question, class 9. The question is to say one difference between basic unit and fundamental unit. Sorry, derived unit. And let me say, class 9, basic unit means fundamental unit. Okay, basic unit is also known as fundamental unit, or also known as primary unit. One difference between. So voluntarily, so anyone can raise the hand, unmute yourself, and please say the answer. I got answer from the previous question from Subham, Jayendra,